Here we have a problem on derivative. There is a function given over here. That is f of t equals to 2 times t cube positive 13 times t square negative 1 over t square. And we have to find f prime of t. That is the first derivative of the given function f of t. Okay, so here this is a function of t. So t is a variable in this function. So as soon as we look at the function over here, we decide it's a rational function because we find variable t in both numerator and denominator. So whenever I want to find derivative of a function which contains variable in both numerator and denominator, so we'll be using the coefficient rule. But here we don't have to use coefficient rule because in denominator we don't find an expression which contains variable, we just a single term which contains variable. So we can do simplification in this function. So first let's do some simplification and then we can start finding the derivative. Okay, first let me write the given function as it is. That is f of t equals to 2t cube positive 13 t square negative 1 over t square. Okay, since t square is a common denominator for all the three terms in numerator, so the denominator t square can be written separately for this, this and this. Okay, let me do it in the next step. That is f of t equals to, so now I'm going to write this denominator t square separately for each term in numerator. Then I'm getting 2t cube divided by t square positive 13 times t square over t square negative 1 over t square. Okay, here then f of t is equal to 2 times. So here we divide two terms with the same base, that is t. Whenever we divide two terms with the same base t, what we can do is we can write the base once and we have to subtract the exponent. That is the exponent in numerator, negative exponent in denominator. This is called coefficient rule in exponent. And here this t square can be cancelled, positive 13 negative 1. Okay, here we have a constant 1 in numerator and variable in denominator. So in this term we don't find variable in both numerator and denominator, but we find variable in denominator. So when I want to find derivative of a particular term which contains a variable only in denominator, what I need to do is I have to bring the variable to numerator so that the process of finding derivative of that particular term will be easier. So if I bring this term to numerator, so automatically the exponent will change its sign. So whenever I move a term from numerator to denominator or denominator to numerator, so the variable in that term will change its sign. So here t square will become t to the negative second power if it comes to the numerator. Also it will be multiplied by 1. So 1 times t to the negative second power. Okay, now so f of t is equal to 2 times. So when I simplify this one, 3 negative 2 is becomes just 1. So whenever the exponent is 1, we don't have to mention. Simply we can write 2t positive 13 negative 1 times t to the negative second power is t to the negative second power. Okay, that's all the simplification I can do. Now I can start finding the derivative of the function we have over here. That is f prime of t is equal to, here the variable t is multiplied by the constant. So when I find derivative, if there is a constant multiplied by the variable, I have to keep the constant 2 as it is, and I have to find the derivative of the variable t alone. So I already said that this is a function of t is a variable. So when I find f prime of t, that is the first derivative of the given function, it is done with respect to the variable in which, the variable that we have in the function. So here f prime of t represents the first derivative with respect to t. So when I find the derivative of this variable t with respect to t, it will become 1 positive. So the derivative of this constant 13 is 0 negative. So now here I can use a power rule of derivative to get derivative of this t to the negative second power. So that is I have to bring this exponent negative 2 in front of the variable and subtract 1 from the exponent. Then I am getting negative 2 times t to the power negative 2 negative 1. Okay, let's do simplification. F prime of t is equal to 2 times 1 is 2, and we can ignore this positive 0, and negative times negative will become positive 2 times t to the negative third power, and f prime of t is equal to 2 positive. So here usually when we give an answer for a question, we don't give it with a negative exponent, but here this t is having negative exponent, so we have to make this negative exponent as positive. So I have already said the reason, that is if I want to change the sign of the exponent, I have to move this one to denominator. So when I move this t to the negative third power to denominator, automatically the exponent will change its sign, then we'll be getting t cube in denominator. So now I got the derivative of the given function, that is f prime of t equals to 2 positive 2 over t cube.